It's a very important class, guys. Okay, I try not to blow things out of proportion, but this may save your life one day if there is actually a zombie apocalypse. Okay, so we got to figure out how long it will take before we're overrun by these sort of creatures. Okay, so what happens is let's start off with I don't know. Let's start off with 10 zombies. All right, which is about a third of my class, which makes sense. And what happens is each day, those 10 zombies just bite one person. That's it, one a day. They're not greedy, um, or maybe they're lazy. I don't know. So I have 10, and then the first day we're to 20. Okay, and then the next day, what happens is those 20. Now we got 20, and each of them eats one, two, or bites. Now we're at 40. So now we have 40 uh, zombies. And the next day, the 40 of them bite two more, or the 10 or 40 bit. So there's 40, right? 10 times 2 times 2, there's 40. And then two more, and then we double that number. Okay? And the next day we double again, and the next day we double again, and the next day we double again. We keep doubling. Okay? And I'm going to let you figure out how long will it take to get to 8 billion people. I don't know how people live in the world, but somewhere like around 8 billion. And if you think there's more, okay, 9 billion. How long would it take if just one zombie bites one person? We double our zombie amount each day. That's it. They're inefficient zombies, or whatever you want to call them. They go around and then they chew on one person, and they double and they double and they double. Okay, so we go from one. Oh, that's depressing. 1 to 2. Okay, and then we double those, and then we double those, and then the next day we double those. Let's see if I need. And then the next day we double those. The next day we double all those. And then when are we all zombies? When are you the last person left? Okay. How many days would it take? Come in and tell me in class. Okay, but let's figure out in general why I wrote this like this. What exponential growth is all about. Well, exponential growth is how you're all alive, first of all. Okay, you were 1 cell, 2 cells, 4 cells, 8 cells, blastocytes, morulas, et cetera, et cetera, et cetera. And you became the impressive combination of billions of cells that you are right now. And that's all through exponential growth. You have asexual division, binary division. You have a cell that cuts into 2, and those 2 cut into 4, et cetera. So let's come up with some equations here that talk about exponential growth. Well, on the first day, actually, we can go back a day. On the very first day, or let's go back to the day before anyone got bit or bitten. I'm not sure which one's right. That's our first day. We had 10 people, 10 zombies. Okay, and we call that day 0. The first day they go out there is day 1, then day 2, then day 3, and day 4, and keep going. Okay, so there's that movie 28 Days Later. We don't get to day 28 here, but we're going to figure out what is our general equation for how many zombies there are on Earth, or how exponential growth works. And if you notice here, I always have 10. I'm always starting off with 10 here. I wrote these numbers funny, right? So we had this here, I said we have 20 times 2, the next 2. But I wanted to show this because each time you have your 10, your original amount, and you multiply it by 2. And the next time you multiply it by 2 twice, and then by 2 3 times. And you can notice here, this 1 is how many 2's there are here. On day 2, you've done it twice. On day 3, you have 2 3 times. Okay, so in general, you start off with your initial amount 10, and then you multiply by 2 times the number of days we've been biting each other, or the zombies have been biting each other. So on the nth day, the general day, so on the 7th day, let's look at the 5th day, the one we haven't done here. That would be 10 times 2 times 2 times 2 times 2 times 2, which is 10 times 2 to the 5th. Okay, and then on the nth day, we have 10 times 2 to the n. And this is, in general, this is our general equation, where A is your initial value, and B is your growth rate. Okay, so this is what we're multiplying by each time, the growth factor. So anytime this is bigger, and you can think about this, if I multiply 10 or any number by anything that's bigger than 1, so by 2 or 3 or even 1.1, this result, the product is going to be bigger than to start with. And this is called exponential growth. And if you ever graph this, we can go to Desmos to check it out, but if you ever graph this, you're going to notice that it's going to look kind of like half a parabola, but it's going to be something that is fairly steep. Okay, it takes off and gets bigger and bigger and bigger. And you got to look at these numbers here. You're not looking at a first difference or a second difference here, you're looking at a multiple. This is times 2. This is twice as big. This is twice as big. This is twice as big. And then that twice as big is a lot bigger, right? If I had, 100 people over, if I had one person over for dinner, I'd double the number of people that are over for dinner. I have 2 people for dinner. Double, but it's only 1 extra person. If I had 100 people over for dinner, I'd double that. Well, it's still just double, but you have an extra 100 mouths to feed, okay? So the bigger doubles, as we just keep doubling, the doubles get bigger, okay? And so this is your initial amount here, and this is your growth factor here, and it's always to the power of n. So initial amount, growth factor, and power of n, and exponential decay is the same thing, except you multiply by smaller numbers in one here. That's it. Okay, so that's growth and decay, and in general, you just work your way through questions by setting up the a, b to the x type equation. So for example, on in our text here, or in our notes, we talked about percent growth at some point. So let's use an example here where something grows at 4%. So you put $1,000 in the bank and it grows at 4% interest. So it grows at 4% interest. Now this isn't as exciting as zombies, but maybe it's a little more practical than getting ready for the zombies. I don't know if it is, but some people would say it is. So if I grow at 4%, when you talk about percentages, you start off with $1,000, okay, and I have that's my A, and then my B is going to be my growth factor. And when you talk about percentages, what you do is you take your percent growth and you add it to 1. So in this case, so your growth rate, and you add it to 1. And how does that work? Well, let's look at this example here. I have 1 plus 4%. Now remember, 4% as a decimal is 0.04. So now I have 1.04. So now I take $1,000 and I multiply it by 1.04 to find out what I have the next year, which is this, 1040. Okay, and let's look at that. Let's try to make sense of that. What is happening here is I'm multiplying by 1.04. The 1 gets me my initial amount back, and then the 0.04 is the 4% growth. So the 1 gets my 1,000, my 0.04 is 40. And if you say, why don't we just do it separately? Why don't I just find out what 40 is and add it on? Well, the problem is when you get to something like this, what happens in 7 years? Okay, so if I keep going 1.04 and I do that 7 times, then how am I going to do that? I'm going to add 40 and I'm going to keep track of that and add, you have growth on growth on growth, right? So this is called compound growth, okay? And we'll talk more about this towards the end of the year if we get to it, when we talk about annuities. The next year, you get 1.04 or 4% on your growth. But how this works, you got to be careful here. It's not just another $40 because you get 4% not only on the 1,000, but you get interest on your interest. So you get 4% of the 1,000, and then you get 4% on this 40. So it gets very confusing. And this is the thing that will make you incredibly rich if you get incredibly rich, or incredibly poor if you get incredibly poor, by investing on something that will grow on itself. Okay, compound growth is huge. And also if you run up your credit card bills, for example, your compound interest that you're going to have to pay could be huge. So here this becomes this times this, which is 1,000 times 1.04 to the power of 2, which is this. And then you keep going and going and going. So if I want to find out how much money do I have on, let's say in 20 years, what you would just do is this, okay, and throw that in your calculator. How this goes in the calculator is 1,000 times, then you use your X to the Y button to the power of 20, straight into your calculator, and then you get the amount here. And this number will be a lot bigger than you think too. Exponential growth is impressive. It grows probably faster than you think it would. Okay, and that's about it. The only other thing you want to look at is if I want to know what the growth rate of something was. So if we go back to example 1 here of our note here, we talked about bacteria growing, and we had 100 and 300 and 900 and 2,700 and 8,100. Okay, if you go and you say, what's going on here? Let's look at the first differences. This grows by 200. This grows by 700. This grows by 1,800, and this grows by 5,400. You look at that and you go, well, that doesn't make any sense. Even the second difference is here, 500, 1,100. That's all right. What's wrong? That's 600. Sorry, 1,200, and then 3,600. You look at these here. There's nothing special about these numbers. If you look at it, there's no consistent first difference, second difference, or even third differences, if you ever got to that. What you do notice, though, is that just going back to the first differences, I look here, and I'll fix this. These guys, that's 3 times as big as that, and that's 3 times as big as that, and that's 3 times as big as that. So what you see is you have the consistent growth rate. And this, if you go back to the first question, that was what we were multiplying everything by. That was our B. This 3 times growth rate is what goes here for our B, what we multiply by. Okay, so look at that, and that's, again, like I said, exponential growth. And when you look at the graph itself, it's going to have a y-intercept. When you graph this, or at the year 0, you're going to graph and intersect at A. So what's that all about? That means here, if I graph this here and I said, here's my money, and now I'm really rich down the road, what is my y-intercept? My y-intercept is at the year 0. So 1,000 times 1.04, or when I started with no interest, and that is just 1,000, right? Because 1.04 to the 0 is 1, 1,000 times 1 is 1,000, and my intercept would be 1,000 right here. Or just know that it's this number here. It's my original value for 1,000. Okay, that's all from exponential growth. Exponential decay will be even easier. Okay, take care.